Today we are going to see about general theory of transmission lines. Need for line parameters. To design a transmission line and to understand the properties of a transmission line. Resistance, capacitance, inductance, conductance are the transmission line parameters. Resistance. This parameter of any transmission line rely on the cross-sectional area of the conducting material. These are distributed parameter networks. That means its parameters are distributed uniformly along the entire length. It is represented by R and its unit is ohms per unit length of the line. The resistance R is given by R equal to rho L by A. Rho is the conductivity of the conducting material, L the length of the transmission line, and A the cross-sectional area of the line. Capacitance. A transmission line is composed of two parallel conducting wires separated by dielectric material. So it behaves as a parallel plate capacitor. Thus it has some capacitance which is also distributed uniformly over its length. It is measured in farads per unit length of the transmission lines. Activity. Inductance. When current flows through a conductor, it generates a magnetic field perpendicular to the direction of the electric field. As the magnetic field varies, electromagnetic flux gets generated in the line. So this EMF now flows in opposite direction with the current flowing through the device which is known as inductance. Its value depends on the current flow through the conductor. Inductance is represented by L. Its unit is Henry per unit length of the conductor. Conductance. The two parallel conductors are separated by dielectric medium, but it is not a perfect insulator, due to which some current also flows through the dielectric. This current is called leakage current and it is responsible for leakage conductance through the transmission line. It is basically present between the conducting wires and is represented by G. Its unit is mho per unit length of the conductor. Relation to other parameters. Transmission line series impedance Z equal to R plus J omega L and its unit is ohms per unit length of the line. Transmission line shunt admittance is given by Y, which is equal to G plus J omega C and its unit is mho per unit length. Angular frequency omega is given by 2 pi f. Characteristic impedance Z0 is equal to root of Z by Y and propagation constant gamma is equal to alpha plus j beta, which is equal to root zy. Alpha is the attenuation constant and beta is the phase constant, where Z equal to R plus j omega L and Y equal to G plus j omega C. Gamma Z0 equal to R plus j omega L and gamma by Z0 equal to G plus j omega C. Summary. The four parameters of a transmission lines are represented as R, L, C and G. They use it to find the properties of transmission lines. They are also called as primary constants of a transmission line. Rectangular to polar form conversions. Some of the examples are shown here. Arithmetic calculations, addition, subtraction, multiplication and division. Some of the examples are shown in this slide. Problem. The characteristic impedance of a uniform transmission line is 2000 ohms at a frequency of 1 kHz. At this frequency, the propagation constant was found to be 0.054 magnitude and angle 60 degree. Determine the values of line constants R, L, C and G. Solution. Z0 equal to 2000 ohm and gamma equal to 0.054 at an angle of 60 degree is given in the question. From this we can calculate omega equal to 2 pi f, which is equal to 6280. We know the values of 2 pi and f. From that we can calculate the r, l, c and g values. The solution for the equations are given in these slides. Assessment. And references. Thank you.